Alright guys, so now what we're going to do is we're going to look at 7.2. So what we're going to be doing is we're going to be multiplying and dividing rational expressions. Remember, the difference between a rational expression and a fraction is in a rational expression you see terms. So you see like x values or variables. Okay, so when you're multiplying a fraction, so if you have r over q times p over s, what we typically do is we multiply straight across. So we multiply our numerators of r times p, and we multiply our denominators of q times s. Alright, so if we make this real, if I have the fraction 2 over 3 times 4 over 5, I multiply straight across, and 2 times 4 will give me 8, and 5 times 3, or 3 times 5, will give me 15. Now the most important thing with rational expressions, as well as with fractions, is that you have to make sure that it is reduced as much as possible. So if I look at the 8 and the 15, nothing goes into both of those, so I am done with this. So one technique that you can use when you are multiplying fractions or rational expressions is cross-canceling. With cross-canceling, what you do is you, to get rid of the need of reducing a fraction at the end, you can cross-cancel, then multiply straight across. So you go from top to bottom to see if you can cross-cancel, and then you go from bottom to top. So really what you're doing is you're creating an x, so you're cross-canceling. Okay, so let's make it real. What I want you to do for this next slide is I just want you to watch it, and then I want you to pause it and then talk yourself through it. So if I have 21 over 10 times 5 over 9, the first thing I want to do is I want to go from top to bottom. So I ask myself, what number can go into 21 and 3, or sorry, what number can 21 and 9 both be divided by? And the answer is 3. Okay, so we're going to divide 21 and 9 by 3. So if I go 21 divided by 3, I'm going to be left with 7. And if I go 9 divided by 3, I'm going to be left with 3. So mark through 21 and 9 and write the answer to step 2 next to the corresponding number. So what I'll literally do is I'll cross out the 21 and I'll write 7, because 21 divided by 3 is 7. I'm going to cross out the 9. 9 divided by 3 is 3. And what I do to make it clear is I will rewrite it. So I'm going to go 7 over 10 times 5 over 3. This is a good technique to kind of get used to, so that you will be able to clearly cancel out what needs to be canceled out. Now we're going to repeat it for 10 and 5. So I ask myself, what can go into 10 and what can go into 5? The answer to that is 2. So I'm going to go 10 divided by 2, which is 5, and I'm going to go 5. I'm sorry, that's totally not right. The answer is 5. I just was rushing. So I'm going to go 10 divided by 5, which is going to leave me with 2, and then I'm going to go 5 divided by 5, which is going to leave me with 1. So then I come up here, I cross out the 10, I replace it with a 2, I cross out the 5, and I replace that with a 1, because 5 divided by 5 is 1. So now I've reduced as much as I possibly can. So now what I'm going to do is I'm going to multiply straight across. So 7 times 1 is 7, and then 2 times 3 is going to be left with 6. And this is how I have my fraction reduced as much as possible. So pause it for just a second and copy this down. Alright, so now what we're going to do is we're going to try a fresh problem. So we got 2 over 7 times 5 over 10. So the first thing I want to do is I want to cross cancel, so I'm going to work from top to bottom. So what two numbers can go into 2 and 10? Answer to that is 2. So I'm going to go 2 divided by 2 and I'm going to be left with 1. 10 divided by 2 and I'm going to be left with 5. Again, I rewrite it so it looks nice and clean and pretty obvious to work with. Alright, now if I go from bottom to top, I got 7 and 5. 7 and 5 are both prime numbers, so there's nothing that will go into both of those two numbers. Now, am I done though? The answer to that is no, I'm not done reducing, because if I have 5 over 5, any number over itself will reduce down to 1. So essentially what I'm doing is I'm going 1 times 1, which is 1, and then 1 times 7, which is 7. And this will be my answer. And the whole reason why is because anytime I have a number over itself, so if I had 3 over 3, just making that up, it will reduce down to 1. So, and I just show it by crossing it out. So, how to multiply rational expressions. The only thing that you have to do added to it is you have to factor it. So, if you could please get out your Factoring is Fun worksheet. So that we can work through multiplying rational expressions. So the first thing that you do is you factor. The second thing you do is you cross cancel. And then the third thing that you do is you multiply straight across. Okay, remember the difference between a rational expression and a fraction is that you're going to see variables. So we have 6 over x times x squared over 12. So first thing we got to do is we got to see if we can factor anything. Now, because I just have a monomial, which means one term, there's nothing that I need to factor here. So I go straight to step 2 to cross cancel. So I go from top to bottom, so I've got 6 and 12. What goes into 6 and 12? That would be 6. So 6 divided by 6 is 1. 12 divided by 6 is going to be 2. So I'm going to rewrite it. So I got 1 over x times x squared over 2. And now I'm going to work from bottom to top. So I see that I have the variable of x. So now what I need to do is I need to find my least variable. So I've got x to the first power and x to the second. So I can divide both of those by x. So x divided by x. So x divided by x is going to leave me with 1. So I'm going to put a 1 right here. And x squared divided by x. Remember, when you divide variables with exponents, all you do is subtract the exponent. So 2 minus 1 will leave me just with x. So I've reduced as much as I possibly can. I look straight up and down, and I've got 1 over 1. It doesn't really help me though. And I'm going to multiply straight across. So 1 times x is going to be left with x, and then 1 times 2 will leave me with 2. So x over 2 will be my final answer. Alright, let's try another one. So we're going to factor, cross cancel, multiply straight across. Okay, so we've got 8p to the third r over 3r times 9 over 2pr squared. Okay, so there's a lot going on in this, but it's still one term. So since it's just dealing with one terms, with the factoring, there's nothing that you can do to factor because they're all monomials. So we're going to work from top to bottom, and we're going to take it one step at a time. So let's first look at the 8 and the 2. What goes into 8 and 2? 2. So 8 divided by 2 is going to leave me with 4, and 2 divided by 2 is going to leave me with 1. The next thing that I'm going to look at is I'm going to look at my variables. So I've got p to the third, and I've got just p. Okay, so I look for my least exponent, so my smallest exponent, which would just be p. So p divided by p leaves me with 1, so I'm going to cross this out, put a 1. And then p to the third divided by p, I'm going to subtract those two, so that will be p to the second. So what you can either do is you can cross out the entire thing, or you can cross out just the 3 and replace it with a 2. I don't really care, either way is a-okay with me. So now I'm going to look at the r and the r squared. My least exponent is up here, so I'm going to go r divided by r, and that's going to leave me with 1. And then I'm going to go r squared divided by r, and that's going to leave me just with r. So this one goes away, I replace it with a 1. This one doesn't all the way go away, and I'm just left with an r. Okay, so this is messy. So what I'm going to do is I'm going to rewrite this to make it more clear. So I'm going to go 4p to the second over 3r times 9 over r. See how it's a lot cleaner to be able to work with. And that's going to be super important. Okay, so now what we're going to work is we're going to work from bottom to top. So if I'm working from bottom to top, I've got 3 and I've got 9. What goes in the 3 and 9? 3. So 3 divided by 3 will leave me with 1. 9 divided by 3 will leave me with 3. I check if I can cancel anything from top to bottom. There's nothing. So I'm going to go 4 times 3 because I'm multiplying straight across. So I've got 4 times 3, which is going to leave me with 12. And then I have p to the second. And then on the bottom, I just have r times r. So that will be r squared. And that is as far as you can take it. Okay, now we're gonna do step 1. We're gonna factor a little bit. So I've got 3 times p minus q over p times q over 2p minus 2q. So the first thing I do is I gotta look to factor because I have some binomials. This one is already factored for us. This one is not. If I have 2p minus 2q, I can do a GCF, and what I can pull out is a 2. So if I pull out a 2, I'm left with p minus q times 2. Okay, so now I can go from top to bottom. Remember, if it looks exactly the same, you can cancel it out. So this binomial looks exactly the same, so I can cancel those out. The 3 and the 2, there's nothing I can do with it. So now I'm going to rewrite it to make it look clean. So I'm going to go 3 over p times q over 2. I'm going to look from p to q. There's no variable that is in common. I'm going to look straight up and down. There's nothing that I can cancel. So the last thing I got to do is just multiply straight across. So I've got 3q over 2p. And I box my answer. Hopefully this is starting to make sense for you just a little bit. Alright, let's try another one. So I've got x plus y over 2x times x squared over x plus y parentheses squared. Okay, so first thing I got is I got to see, is there anything that I can factor? Well, I got a binomial that's squared, and then I've got 2 monomials. What I could do to make it a little bit clearer, you don't have to, you could go x plus y times x plus y, because x plus y squared just means that you're running whatever's in the parentheses twice. Might make it clearer for you. If you don't need it, don't do it. Okay, so now I'm going to look to cross cancel, so I go from top to bottom. Remember, whatever is exactly the same can cross cancel, so this cancels and this cancels, leaving me with 1. So I have 1 over 2x times x squared over x plus y. Now I'm going to go from bottom to top. What I notice is I can't do anything with that 2, but the x's I can deal with my least exponent. So I've got x and I've got x squared. So we can divide both of these by x. So x divided by x leaves me with 1. So this gets canceled out and leaves me with 1. And x squared divided by x will leave me just with x. So this cancels out, leaving me with x. I look straight up and down, there's nothing else I can cancel, so I've got x over 2 times x plus y. Now, you can totally leave it just like this. Whenever you're dealing with rational expressions, as soon as you have cross-canceled and reduced as much as possible, and you multiply straight across, this is 100% correct for me. You do not need to distribute the 2. If you want to, you can. You won't get points taken off. But for timing's sake, I wouldn't necessarily suggest to factor that out. But you can if you want to. Okay? So now, we're getting a little bit harder, but not much. So we got 2m minus 1 over 3m plus 2 times 5m minus 2 over 1 minus 2m. Alright? So first thing I see is I have all binomials. So since I have binomials, that's 2 terms, I'm going to look for a difference of perfect squares, or I'm going to look for a GCF. So I don't have a GCF there, so I can't factor that. I don't have, it's addition, but I don't have a GCF. There's nothing I can do with this one, and the 1 minus 2m, there's nothing I can do with that either. Now, so now I'm going to look from top to bottom. Initially when I look at this, I say, oh no, there's nothing to cancel. But remember from our previous notes, when you have the exact same terms, but they're in opposite positions, they're opposites of each other. And opposites will always reduce down to -1. So I've got -1, and I always put that in my numerator, and if you want to put just as a placeholder a +1, you can, but I always put my -1 in the numerator. Now, when you're dealing with just binomials, it makes it a little bit easier to look at. And if you want to, you don't necessarily have to rewrite this. I'm going to for consistency's sake though. So I'm going to go negative 1 over 3m plus 2 times 5m minus 2 over 1. Okay, now if I look from bottom to top, there's nothing that I can cancel out there, so I just multiply straight across. So I've got negative 1 times 5m minus 2 over 3m plus 2 times 1, so I don't have to write that. If you want to put in parentheses, you can, but you don't have to. Now, again, this is 100% correct for me. If you do desire to distribute that negative 1, you can totally do that. It's not necessary though. Okay, so this is about as hard as it's going to get, and it's just because it takes a little bit more work. So each one of these, you're going to have to factor it. So I want you to pause it for a second, and I want you to factor each one of these using your Factoring is Fun worksheet. Alright, so if I have x squared plus 7x plus 10, I have three terms, so it either can be an a equals 1, a doesn't equal 1, or a perfect square trinomial. I see that this is an a equals 1, so what I do is I set up my two parentheses. I go x plus plus, so it's going to be plus plus, then I find my factors of 10, 1 and 10, and 2 and 5. I have to use addition to get to a positive 7, so it's going to be 2 and 5. So I put a 2, put a 5. Doesn't matter which one I put which because it's both positive. Now if I go down here, I've got 3x plus 6. So first thing I see, it's a binomial, so two terms. Whenever I have two terms, it either could be a GCF or it could be a difference of perfect squares. This one is definitely a GCF. What I can pull out is a 3, and I'm left with x plus 2. Okay, up here, I got 6x minus 6. Two terms, so when it's two terms, it either can be a GCF or it could be a difference of perfect squares. Again, this is a GCF, so I can pull out a 6 and I'm left with x minus 1. And then I've got x squared plus 2x minus 15. So the first thing I see is I have three terms, so it either can be an a equals 1, a does not equal 1, or it could be a perfect square trinomial. This is an a equals 1, so I put my two parentheses. I go x plus minus, so it's going to be plus minus, and I find my factors of 15. So 1 and 15 and 3 and 5. Now because my signs are different, I have to use subtraction, and I have to get to a positive 2. So I'm going to use the 3 and the 5, but my order is super important because I need to get to a positive 2. So I'm going to go 5 minus 3. So my 5 has to be positive and my 3 has to be negative. Okay, so I've cleaned it up as much as I possibly can with factoring. Now what I'm going to do is I'm going to do step 2 to cross cancel. So I go from top to bottom. If I go from top to bottom, the x minus 5's cancel out, so I'm left with x plus 2 over 3 times x plus 2 times 6 over x minus 1 over x minus 3. Okay, now I'm going to look from bottom to top. So I know my 3 and my 6 will definitely cancel out. 3 divided by 3 leaves me with 1. 6 divided by 3 leaves me with 2. These aren't exactly the same, so I can't cancel that out. But if I look straight up and down, the x plus 2 goes away. Okay, so really I'm going 1 times 2 times x minus 1 over x minus 3. After a little bit of practice, I think it's easier to deal with binomials and trinomials where you have to factor because it becomes very clear when things can cancel out opposed to dealing just with monomials or one terms. Okay, so this is about as hard as it gets where you actually have to factor each term. So now what we're going to do in the last part of today is we are going to be dealing with dividing. So when you divide, you change the operation to multiplication and find the reciprocal of the second rational expression. Okay, so the thing that I want you to remember is keep, change, flip. Okay, so you want to keep, change, flip. And then you're going to follow the rules of multiplication, which is to factor. Then you cross cancel. And then you multiply straight across. So as soon as you see that it's a division problem, the first thing that you want to do is keep, change, flip, and then we're just going to follow the rest of what we've been doing. So to keep, change, flip, what this means, if I have 3 over 10 divided by 9 over 5, you keep the first fraction, so you keep the 3 over 10. You change from division to multiplication, always. And then you flip the last one or find the reciprocal. So 9 over 5 would be 5 over 9. Now, because this is just fractions, we can't factor anything, but we can cross cancel. So 9 and 3, what goes into 9 and 3? 3. So 3 divided by 3 is 1. 9 divided by 3 is going to be 3. 10 and 5. So I have 1 over 10 times 5 over 3. So 10 and 5. What goes into 10 and 5? 5. So 10 divided by 5 is 2. 5 divided by 5 is 1. So I've got 1 over 6. Multiply straight across. Okay, so now let's do it with the rational expression. So I'm going to read the problem first. I've got m squared minus 4 over m squared minus 1 divided by 2m squared plus 4m over 1 minus m. So first thing that I've got to look at is I have a division sign. Whenever I see a division sign, I want to keep, change, flip. So I'm going to rewrite it with keep, change, flip because that's my first step. So I got m squared minus 4 over m squared minus 1 times, change from division to multiplication, and then I flip it, so I got 1 minus m over 2m squared plus 4m. What I've noticed in the past is people will factor it first and then flip it, but most of the time they forget to flip it. So I would always say the first thing that you want to do when you see a division problem is to keep, change, flip. Alright, next thing that you want to do is you want to factor this. So in order to factor it, I've got to look at each term. So if I have m squared minus 4, I got two terms, it's a binomial, so it either can be a GCF or it can be a difference of perfect squares. So this one is actually a difference of perfect squares. So I would go the square root of m squared, which will be m, the square root of 4, which is 2. So I set up my binomials, I go plus minus, so that would be m plus 2, and then m minus 2. Come down here, so I got m squared minus 1, two terms. It could either be a GCF or it could be a difference of perfect squares. Again, this is a difference of perfect squares. So I take the square root of m squared, which is m. I take the square root of 1, which is 1. Set up my parentheses. I get plus minus, so it's m plus 1 and m minus 1. Alright, so I got 1 minus m, nothing I can do to factor that one, but I've got 2m squared plus 4m, so first thing I got to see is it's two terms, so it either could be a GCF or it could be a difference of perfect squares. Because it's addition, my only option is going to be a GCF, and what I can pull out is I can pull out a 2m. When I pull out a 2m out of my first term, I'm just going to be left with m, and then plus 2, because 4m divided by 2, I'm going to write that actually, 4m divided by 2m, m's cancel out, and 4 divided by 2 is 2. Okay, so I factored as much as possible. So keep, change, flip, I factor it. Now I get to cross cancel. From top to bottom, I see that the m plus 2 can definitely cancel out, and that's it. So I'm going to rewrite it to make it cleaner. So I got m minus 2 over m plus 1 times m minus 1 times 1 minus m over 2m. Okay, so next thing that I notice is I had to go from bottom to top. And initially if I look at it, I say, no, there's not much of anything that I can do. But remember, opposites. So I've got m minus 1 and I've got 1 minus n. They are subtraction and they're in opposite positions. So opposites reduce down to negative 1. And if you want to put the 1 just for placement, you can. I check up and down to see if there's anything I can cancel. There isn't. So I multiply straight across. So I go negative 1 times m minus 2 over 2m times m plus 1. And remember, when you do this, you don't have to distribute the negative 1 or the 2m to the binomial. This is 100% correct for me. Alright guys, hopefully this helped. Now what I need for you to do is I need you to do the homework assignment for 7.2 and come to class if you have any questions. Thank you.